In this video, I'll talk about Ohm's Law. What is Ohm's Law? Let's say you have a conductor here. It could be brass, it could be copper, it could be iron. Then we apply a potential difference, and this potential difference could be due to a battery, or this conductor is inside an electric field. Let's say we have applied a potential difference here, the V. This V is the potential difference between these two ends. Between this end and this end, we have created a potential difference. And if this is a conductor and we have applied a potential difference, that means there will be a current passing through this circuit here, or current passing through the conductor. And the current in this conductor is directly proportional to this applied potential difference. Remember, the current is the outcome. The potential is the source of the current. So current in this circuit or in this conductor is directly proportional to the applied potential difference. Okay, and this is a symbol for proportionality constant. Proportionality. Okay, so if we remove this proportionality, then it will be V over R. So this is now an equation now. So this one just tells you relationship, that if we increase the potential, then the current will increase. Now this is an equation. So this constant R is called the resistance of the material. What does this mean now? Greater the resistance of the material, smaller will be the current. So the current in the circuit is influenced by the two parameters. One is the applied potential and the other is the resistance. This is an external thing and this is the materials thing. Okay, it does depend upon the length, the cross-sectional area. So there are many materials which follow V equals to IR relationship, and that I call the ohmic material. In general, we call the ohmic material for those materials for which if we plot a graph of the potential difference and the current, if it is a straight line, then we call that material as a ohmic material. Right, just a plot of graph between the voltage and the current, or if the plot of the current and the voltage is a linear, then we call that as an ohmic materials. And there are many materials which does not follow quite this relation, that it is held by some other relationship, then that material is called non-ohmic material. For example, diode. I won't be able to describe what diode is in this video. Maybe I will just make another video of what diode is. If we plot a graph of a diode with the potential difference along x-axis and the current along y-axis, then a graph will look like this one. This is not just a simple linear relationship. So this kind of material is called the non-ohmic material. So for this kind of material, the resistance is dependent of the applied potential. So in fact, the resistance itself is a function of the potential. So now you can see here, at this point, I'm changing the potential, but the current is not changing at all. Okay, I'm changing the potential here and the current is not changing at all. What does that mean? That means that at this point the resistance is extremely high, almost infinity. It is extremely high. But here now, after this voltage, if we apply the potential, if we increase the potential, then the current starts increasing dramatically. So at any point the slope of this line, the inverse of the slope gives you the resistance value. Okay, so inverse of the slope, here the slope is 0, so if I take the inverse it will be infinity. That means the resistance is infinity. So if you have to find out the resistance at any value, you have to use 1 over slope. And remember, the I is along y-axis and the V, the potential difference, is along x-axis. But for ohmic material, as it is a straight line, the slope at any point is constant. And that's the why we call this one as an ohmic material. It follows a simple equation, V equals to IR, a simple relations here. Okay. So in order to describe a little more about Ohm's law, I'm going to use a simulation here. Just 1 second. Okay. So this simulation tells you how does the current changes when we change other parameters, example, the voltage and the resistance. So here now I'm going to change the voltage, and then what you have to look at the current value here. Right now this one is 9 ampere. So I'm changing the voltage now. As I'm increasing the voltage, the current is increasing. Okay, and now I'm decreasing the voltage, the current is increasing, and it is changing linearly. So this is an ohmic material. Okay, the other control I have is the resistance. If I increase the resistance, the current is decreasing, and if I start decreasing the resistance, the current starts increasing. Okay, so the current is the outcome. What does it show? That as smaller the resistance, the bigger the current is. Okay, or greater the voltage is, greater the current is, or as smaller the voltage is, as smaller the current is. So this is it from the Ohm's law. If you have any questions, any confusions, write to me, and do not forget to like, share and subscribe the channel. Thank you very much.